All right, good morning, guys. 7:30 in the morning, and I'm the only one at school yet, so I'm going to start a recording here. Brought my green screen to school. We are on 1.5 still, but this is like day 3. We did parent functions, then we did a whole lot of video time on transformations, and now we're on Piecewise. This kind of reinforces transformations when we get to the graphing part. But a piecewise function is simply, let me show you an example, this kind of thing here, right in here, where we're going to talk about all different places it can be evaluated. So piecewise is a function made up of 2 or more functions, each with its own domain, often resulting in a discontinuous graph. So it jumps from rule to rule. Now, what you have to remember when you graph these is that it's an open circle if we have a less than or a greater than. It's a solid filled in circle if we end at the ends of a less than or equal to or a greater than or equal to. The trick is, guys, if they overlap, if they're not continuous, you don't try to draw both. You just draw the filled in one, okay? So if they meet up, you just give me a solid circle and say it's included in one rule or the other or both, and that's it. All right, so evaluating a function is, we did this earlier when we started functions. So we just need to figure out which rule the -5 goes into. And I had to start this video all over again because I thought -5 fell in here. But on a good day, -5 is less than -3. So we're going to say that this is actually going in this rule on try 2 of the video today. So it's 2 times the absolute value of -5 minus 5. Now sometimes students get confused and think that makes everything positive right away. It actually doesn't. It's like parentheses first. But -5 minus 5 is -10. Absolute value makes it positive 10. And then times that 2 out front makes it 20. All right, that matches what I had in my notes a little bit better. I got confused the first time around. That's what happens when you try to record in the morning. Okay, put a 2 into one of these functions. Now, positive 2 does fall between -3 and 7, so I have to put a 2 in here. Now, there's a -1 out front. You could write it as a -1. Then put the 2 in and square it, and then plus 4 times 2. So this becomes 4 times -1 is -4 plus 8 is 4. Do all this on your calculator, that's fine. Then last one here we have is a 7. 7 is not less than 7, it is greater than or equal to, so we're putting it in this square root guy. So we have square root of 2 times 7 plus 6. That would be 14 plus 6 is 20. I'm not going to be picky on a problem today about radicals. I would like you to practice simplifying, but if you give me a decimal, that's okay. Square root of 4 is 2, square root of 5. All right, so there's the simplified version. We're going to be graphing these in just a minute, so I just want to quickly go over. This is an absolute value, so it would be a V shape. This is a squared, so it would be a parabola. It does have a negative. It would open down for that piece. And this is a square root graph, which is this shape. Okay? When we get there, we'll talk more about those, but that's a review of your parent functions. One more evaluate real quick. This has our favorite question mark, greatest integer function. Okay? And remember that is on the calculator. Let's just start at the beginning and we'll get there. -3 is not less than -4. -3 would fall in here. So it says to just answer 8. That's easy. -8 is less than -4. It's further to the left. So we have to evaluate this guy. 1/2, of -8 cubed plus 7. Yep, I don't know off the top of my head what -8 cubed is. I'm going to cheat and type 0.5 times -8 to the third. Now remember, a negative to the third power should still be negative. And then we had a plus 7, so I got arrow to the right. All right, that gives me a negative 249. All right, then a 3.1. This is the one going into the greatest integer function. If you put a 3.1 in here, these little goofy parenthesis things are the greatest integer or step function. If you were to be drawing it, we'd sometimes call it the steps. But the definition is the greatest integer less than or equal to. So it's a round down function, I like to call it. So if I evaluate first what's in there, I get negative 0.9. Now, I have to round down to the next integer value, which when you're doing negatives, would round to the left to be negative 1. I just want to review with you, though, if it had been positive 9 and we rounded it down, it would have rounded down all the way to 0, because the next integer less than 0.9 would have rounded down to 0. Okay, that was just an extra example, not an answer to that question. All right, now we're going to draw piecewise. It's really important that you use pencil. I'm going to teach you three different ways to do this. One way is to just sketch the graphs and then erase the parts that don't work. One way is to try to sketch only the parts of the graph that do work. And the third way is on the calculator, but really the calculator is only going to be your friend to a point, because you guys have to be able to draw these accurately and use open and closed circles and all that fun. All right, so this first one is an absolute value function, which means it's a V shape. It has been shifted left 3 and down 1. So if I go left 3 and down 1, and the V shape means that it's, and the branches, there's no stretch out here, so the branches are just going up 1 and over 1. Okay, so that's the absolute value piece. And this says 2x minus 5. I'll do that in a different color. Just a linear function, goes down here at negative 5. I think we might need to just get rid of my head for a minute here. Can we do that? Well, I can move it down. All right, negative 5. It's down here. Maybe I can put me way up here in the corner. How's that? All right, negative 5 is here. And then it's supposed to be going up 2 and over 1, up 2 and over 1, or back this way. Now, if you're not using pencil, you're in trouble, because this is not what's happening, because this piece only works when x is less than 0. That's this side. So for the red function, I need to stop when I get here where x equals 0. So I need to erase over here, and I need to decide what kind of circle it ends with. It says less than 0, so I do not include this point right here. Open circle. But keep going less than 0 would mean this branch goes on to the left. All right, greater than or equal to, eraser again. It says greater than or equal to 0, so at x equals 0, which is the y-axis, this one does not go to the left, it only goes to the right, because it says greater than or equal to, and it does say or equal to, so I get to include a big old dot here, and then off to the right. Now, this one was a line, by the way. All right, the domain, as we go left to right, this would continue to the left, so the values over here are okay. We get here. Now, does this pass the vertical line test? Yes, it does, because this point is not included and this point is included. So everything up to 0 is okay. Jumps down here, 0 works, and we keep going off to the right. So as we go across, actually all values are included. And as long as this says there's no gap in here, so it goes less than 0, 0 and up. Its domain is all real numbers. The range is bottom to top. Nothing goes below down here. We don't ever go below -5. But this guy points up forever, so bottom to top, it goes up. Now, there are places where there's more than one y value. That's okay. You just can't have more than one x. And it points up forever, so we just say to infinity. And this was a solid circle down at the bottom, so we get the square bracket. It is discontinuous, meaning it has a jump, and the jump happened at x equals 0. So yes, at x equals 0. All right. Second example. Let's this time, I don't know if this is a good choice. I'm going to try this time to graph only the pieces that we really need. So we'll see how that goes. -4 minus x is a line. It is the same as -x minus 4, so it's down here 1, 2, 3, 4. And it's going down 1 and over 1. But we don't want that whole line. We want only the pieces less than or equal to -3. Well, -3 is way over here on the x, and we want the pieces going to the left, which would be these pieces up here. So we have to erase or get rid of all this over here and only graph the piece to, whoop, I have the eraser instead of the pen. There we go. And going to the left, which in this case, even though the line has a negative slope, that means it's going down to the right, but to the left it's going up. All right, we have a solid circle because it was less than or equal to. All right, I'll talk about another way to do that and show you on the calculator in 1 second. All right, let's switch to blue here. This is a parabola because it's got a squared and it's got a negative, so it's opening down. And it has no shifting left or right, so it's at 0, 0. And it says all the values greater than -3. Well, here you might just put the -3 in to get an idea. If you put a -3 in and square it, becomes 9. -1/2 times 9 would be -4.5. So when I put in a -3, I got out a -1, 2, 3, 4.5. And that's actually an open circle down there because it was greater than, not greater than or equal to. If you want to wait till the end of the problem to worry about the open circles, that's okay too. Open or closed, I should say. This is a parabola, so I'm going to keep putting some values in. If I put a -2 in, it would become 4. Half of that would be -2. So -2, -2 is a point. -3, -4.5 was a point. If I put in -1, I'm going to get +1. Half of that would be -0.5. If I put in a 0, I get out a 0. And then it has an axis of symmetry, so I should be able to figure the right-hand side. So -2, -2, -1, -1/2, 0. And then it's doing the same thing over here. But it keeps going. So this shape is a parabola that keeps going. Okay, so let's finish this and then I'll talk a little about the calculator. Domain left to right. Well, it skipped rule or jumped rules here from less than -3 to greater than -3, but 3 was included. So the domain left to right is all real numbers. And I think bottom to top we're good even. This one's going down forever and this one's going up forever. So if we go bottom to top, we have all real numbers. Now, it was also discontinuous at x equals -3. All right, I just realized I did this wrong on my notes. This one is right though. All right, So I want to show you on the calculator a couple things we could have done. We could have gone to y equals and typed the two rules in, negative x minus 4, okay, negative 4 minus x, same thing, and a negative, and I'm just going to cheat and write 0.5 x squared because I don't want to write a fraction, take time to put parentheses and everything. Okay, now you could do a zoom 6 and look at the graph. Okay, you just have to figure out which pieces you need. My suggestion for the next part would be just go to the second graph or the table here. If you're having trouble, you can go second window and make sure your table looks like this. It can start at 0, count by ones, auto, and then you can scroll up and down. Now, this one changed value at -3, so it was -3 and less. So we would graph these points, -3, -1, -4, 0. Yes, -5, 1 should be the points that we graphed. Let's check. Okay, here, -4, 0, -5, 1. Those were the points we were graphing for that one. Then the other equation, we're using the red now. Okay, and the red was the squared. If you're confused at this point, you could get rid of that guy. And we're graphing this, and we want only values greater than -3, so we can scroll down here and start with this one and keep going. Whoa, I don't know what just happened. Okay, so -3, -4.5, -2, -2, and so on. All right, I have a surprise for you. There is a way to make the calculator do this for you, but it's a little tricky. What you have to do is say, and I don't think you need parentheses, we'll find out in a minute here. At the end, you say divided by, the whole function divided by, it's a way of saying if, and then you put in parentheses, and we say x, and to say less than or equal to -3, I hope I'm doing this right. It's second math, it's the test menu. Okay, second math is the test menu, and you would pick number 6, less than or equal to, and we have -3. All right, I'm thinking I might have needed parentheses around this first little piece, so I am going to check the graph. Ooh, sweet. Look, it's doing the right graph and it stopped at -3. All right, then I go to the second one, and the division is just because it's, if you divide, it changes the range, or the undefined, where it's undefined. So the symbol is just divide to say if, okay? And then we're going to have to, you always have to have parentheses around this part. X is, again, it's second math for test. Greater than is choice 3, was -3, parenthesis, graph. All right, that's what it should look like, but it won't tell you the pieces, okay? It won't tell you whether it's open circle or closed circle. I'm sorry, that's what I'm trying to say. Now, there's an even better way if you're using the emulator or the newer calculators, and I'll show you on the next one. The very newest calculator, my own calculator, does not have this feature, but the emulator and the very latest ones do. All right, I was actually thinking I was going to skip this number 5 because I am not about the rational function yet. I'll do it in the notes or maybe at the end of the video, but all right, I'm skipping down to number 6. Number 6 has a linear function. This is also a linear function, but it's a constant, so that would be a horizontal line. And then this is a squared, so it's a parabola that opens up. All right. I'm going to do this by hand first, so I'm going to talk you through it. The first piece is a line that starts up here at 8, 2, 3, 4, 5, 6, 7, 8, and is going up 3 and over 1, or down 3 and back 1, has a positive slope because as you go left to right, it is going up. All right, but I want the pieces only to the left of -4, so I go 1, 2, 3, 4. Wow, way down here. I only want to keep these pieces on this side, so I'm going to go back and erase all of these pieces and that little line. And the only ones I'm keeping are these, and I got to decide, do I need an open or closed circle? Less than or equal to means I include that value, which happened to be at -4. If I put that in, I get -12 plus 8 is -4. So there was a solid circle at -4, -4. Sometimes it helps me to find the exact endpoints. This is an easy peasy one. It is just a horizontal line at -1. Ooh, right there. But we get to erase the pieces to the left of -4, and it only goes to +2. And then the -4 was not included, so this guy is an open circle, green pen. And this guy had an or equal to at the 2, so he's a solid circle. And then we have a parabola who has been shifted right 2 and down 5. So its vertex is right 2 and down 5. 1, 2, 3, 4, 5. This is the vertex. So it is going up on this side and up on this side. Well, guess what, guys? We only care about the values to the right. So we're actually going to end up with half of a parabola because we only care about values 2 or greater. And I already messed up because this should have been an open circle, but we could have fixed that later. So if we were to put a 2 in here, we'd be at -5, but it's greater than that. So we have to, at 2, -5. Students get confused. It does go right up to, so it's okay to put the 2 in and find that it's at 2, -5. You just have to make it an open circle. And then you could put on your calculator and put in a 3 and see what happens. It goes to -4. If you put a 4 in, let's see, 4 minus 2 is 2. It's at -1. If you put a 5 in, you would have 3 squared is 9, minus 5 is 4. 1, 2, 3, 4. Okay, so it is climbing quickly, not steadily. It's not linear, to the right. All right, let's do domain and range real quick. As you go left to right, it jumps around, but this point is included, all these points are included, this point is included up here, and then it goes off to the right, so this is all real numbers. And the range, going down we have everything, this one's here, going up we have everything. And the discontinuities happen at his 2 jump discontinuities at 1, 2, 3, 4, -4, and at 2, which is where it jumps up here in the rules. You do have to be careful. Sometimes those match up. I don't think I have a good example of where they match up, but and then it doesn't jump. All right. I wanted to show you on the calculator. That's right. The really cool feature I found on a video. If you go to math and you can arrow down a long way, or you can actually arrow up, look what's down here. There's a little function on the newest calculators called Piecewise. This is so cool. Oh, I wonder if I have to be at y equals first. Yeah, I think I do. All right, go to y equals, clear this stuff out. Sorry. And then you go to the math and arrow up. Okay, so in the y equals, math and arrow up, find this piecewise. My own calculator does not have this. It says how many pieces, so you'd arrow to the left, or Yeah, maybe. Type over. I don't know, how do you change that? All right, I'm not going to worry about it. I need 3 pieces. Why is it flashing at me like that? All right, I need 3 pieces anyway, so I'm going to say okay. Maybe it's not happy. All right, let me try this again. Maybe this calculator doesn't really do this? Just kidding. I thought I practiced this. Y equals math, arrow up, piecewise. It has 3 pieces, so I'm okay. All right, it isn't going to work for me. I have no idea why. What it does is bring up boxes and lets you type this same stuff in. I'll do it the old-fashioned way, though, for you. You would put 3x plus 8. You would put divide. And you have to have parentheses, and it's second math. Oh, not yet, it's not. It's x first. And then it's second math. And we needed a less than or equal to, which is choice 6, and a -4. And then I'm going to scroll down, and it's just -1. And divide and say parenthesis -4. Second math, less than is 5x. And then it's less than or equal to, so back to second math, choice 6, and that was a 2. And then the last one is parenthesis x minus 2 squared minus 5 divided by parenthesis x second math. See, I can't type. Greater than only, which is choice 3, 2, close parenthesis. Let's see if it graphs right. Ooh, something is messed up. That -1 is not supposed to go that long. What did I do wrong, guys? I wonder if because if it's a constant function, I don't need the divide. I don't know what else would be wrong with that. I think it's because it doesn't have an x. So it's not dividing out anything. Interesting. Well, you'd have to fix that and make sure you only include the points from -4 to 2. I don't know how to make that work. It probably works if you have that piecewise function, which is again under math. You guys will figure it out. I can put some video links in if you need me to. All right, I'm going to do one more and do the last one by hand. Number 7 is a constant line at 7. 1, 2, 3, 4, 5, 6, 7. It's a line up here. Okay, but I only want the pieces from -1 and left because it says less than -1, and it had less than only, so I want an open circle, which I drew very big. Okay, x cubed minus 1. Parent function is this shape, but you might want to put some points in. It says include all the points from -1 to -2. So I'm going to put in -1 to +2, I think I said. Anyway, -1, 0, 1, and 2, because those are all the points from -1 to 2. I'm going to cube them and subtract 1. You could type it in your calculator and find these values in the table. If you cube this, you get 1, minus 1 is 0. You cube this, subtract 1 is -1. You cube that, subtract 1 is 0. What? Yeah, I did that wrong. -1 cubed is -1, minus 1 is -2. I messed the first one up. And then 2 cubed would be 8, minus 1 would be 7. So those are the points I need to be plotting for that piece of our piecewise function. -1, -2, 0, -1, 1, 0, and 2, 7. The important thing, though, is that you know the shape of the parent function, because it looks like I can't tell what I'm doing, but it's supposed to be this shape at -1, because it's been shifted down, is an inflection point, and then it's going up, 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 up. All right, and it did have a solid included circle on both ends. Oh my goodness, that is a horrible graph. Let me try to erase one little piece in here. The concavity is supposed to be kind of switching. Oh, I can't do this. Like that. All right, I didn't do a very good job. Anyway, all right, then we have a square root graph, which normally goes like this. This one has a negative, so it's going like this. And we can put in values 2 and greater. You should put in 2, even though it's an open circle at 2, because it goes right up to that spot. So if I put a 2 in here, square root of 4 would be 2. This would make it -2 plus 1 is -1. So at 2, I got out a -1. Oh. At 2, I got out a negative. Oh, I am hopeless. No, nobody's ever hopeless. I'm just helpless, maybe. At 2, I got out a -1. If I put in a 3, I get the square root of 6 and negative square root of 6 plus 1. All right, let's just get a decimal here. Negative square root of 6 with a plus 1. It's -1.44. Where can I get that? I'm going to put one more in. I'm going to go really far out, like, let's see. If I put an 8 in, then I'd have 16. The square root of 16 would be 4. -4 plus 1 would be -3. All right, and you could again use your calculator to find some of those. If you just typed this in your y equals and went to your table, it would help. Okay, so at 2, it's down at -1. Had it only a greater than, so I'm going to use an open circle. And then at 3, it was down to -1.44. But out at 8, does it even go that far? 3, 4, 5, 6, 7, 8. Oh, it does. Good. It's down to -3. Again, not helpful unless you know the parent function shape, which is doing this. Okay, that was not good. Should be a curve, okay? All right, let me finish this video off strong here. Left to right, we had less than -1, -1 to 2, and 2 and greater. So the domain was all real numbers. Bottom to top, this one does keep going down. I didn't do a very good job of making that happen. But it stops up here. It never goes above 7. It does go up to 7, but never above. So this would actually be this. And it does have a discontinuity at x equals -1, and again at x equals 2. All right, I'm going to go back and do that number 5 in the notes, or maybe even on the video here, but let's stop at 34 minutes for this horrible long video. Watch video 2 and then do the practice. Actually, I think there is a practice that just covers part 1. It's only 4 problems. Anyway.